Okay, so oil pad thickness you got HO maximum. Okay, now how to solve it? How to solve it sequentially? So if you one problem is given, you see some flow rate is given, your separator sizing you have to do, and let's say fluid viscosity, fluid flow rate, all these parameters are given. The solving steps will be like this. First, compute H max. Okay, how much oil pad thickness possible you calculate using 50% filled gravity separator. If you are not considering the 50% filling, then equation will be different. So presently for simplicity I am using only 50% filled separator. Okay, and then you have to calculate fraction of the vessel cross section area occupied by water phase. So A water by AL you have to calculate. Okay, and this formula is like this: A water by AL or total vessel, actually not liquid, total. Formula is 0.5 Q water TR water, retention time of water, TR oil plus TR water Q water. Okay, and if we have to derive this formula, it is like this. Drive. Okay, derivation will be like this: A equals area, total area, Q into T into effective length. Okay, Q means flow rate, means cubic feet per second, T is second, and so units will be like this. Dimension analysis: cubic feet per second into second divided by feet. So finally second cancelled, ft, so ft square coming. Okay, so area is ft square. Now Q flow rate is equals 6.49. We have seen this constant term into 10 power minus 5 QO. Q water case also the formula will be same, equals, I am putting some suffix water and oil. So 6.49 into 10 power minus 5, 10 power minus 5 QW. Okay, so T oil equals 60 TR oil. 60 means second. You are converting into from minute to second. TW equals 60 TRW. Okay, and area of oil 3.89 10 power minus 3 into 10 power minus 3. This is important by minus 3. Q oil TR oil effective length. Similarly for water, A water 3.89 into 10 power minus 3 Q water TR water divided by effective length. Okay, and we put some equation number also. Let's say AW, this one, QT, this is 1, this is Q oil, this is 2, and this is 3, and this is 4. Okay, and this is coming actually from 1, 2, 3. Okay, now A total area is equals 2 into AO plus AW, because 50% filling was there. Okay, because 50% water, oil, gas. Okay, so this was 50%. Okay, so whatever area you are getting here, AL total area, A total area equals AAL plus A gas maybe. Okay, so but AL and A gas is equal, that's why it is coming like 2 times of AO plus AW or AL. Okay, so I can write this is 5. So 4 and 5, this equation gives, if I divide, AW A equals 0.5 QW TRW divided by TRO Q QO plus TRW QW. Okay, so this equation is 6. Now again point 3. Okay, now previous slide you have seen this first you have to calculate H max, then AW by A you are calculating. Then next step is that point 3 is that from figure, this figure is given, figure is beta equals H O divided by D, and this one AW by A, water area divided by total area. Okay, so from this figure you have to calculate beta. Okay, then next step you have to do D max calculation. Okay, how D max will be coming? D max equals HO max divided by beta. Beta equals HO by D. Okay, HO max by D or HO max by D max. Now you have to calculate any combination of D and LEFF, and you have to calculate a whole. You have to calculate whole LESS, D, slenderness ratio, other parameter you have to calculate. Okay. So seam to seam length in horizontal separator also you have seen LSS. Okay, for formula differs actually, so you do not use same formula. L effective length plus D by 2. Okay, seam to seam means total length of separator, and effective means certain amount will not be used for separation. So effective length will be lower than seam to seam length. So LSS normally it will be less than 4 or 5. Okay, so sometimes it can be maximum, it can go 4 or maximum 5. So let's say 4. Okay, to prevent re-entrainment, re-entrainment of liquid at the gas liquid interface. Okay, if a separator is based on liquid capacity, higher slenderness ratio acceptable, but still recommendation is that less than 4 LSS should be there. Okay, so procedure of sizing is like this. First TRO and TRW you select. Okay, then HO max you calculate from previous table or from formula, and you can use 500 micron or micrometer droplet size for water. Okay, when water is moving inside oil pad, HO formula is that HO max 1.28 into 10 power minus 3 TRO del SG dm square by mu. Okay, for 500 micron the formula HO max will be 320 TRO del SG by mu for 500 micron. Now you calculate A by A, AW by A. Okay, so the formula is 0.5 QW TRW divided by QO TRO plus QW TRW. Okay, so you use this formula, then you calculate HO by D. Once HO by D done, again calculate HO max, calculate D max. Once you get HO by D, then you can get D max actually. Then after that you can get beta from table, again you can calculate. So we'll see when we'll be solving problem, we'll see how whole procedure is going on. Okay, so in that case also you are using DLEFF formula, then after that you are calculating retention time based diameter and LEFF relationship. Okay, then seam to seam length you are calculating. LSS equals L effective plus D by 12 or 4 by 3 L effective for liquid capacity. This is for gas capacity. Okay, so later we will see how actual steps are going on one by one. Vertical separator sizing. Okay, so vertical separator sizing, again first you start with gas capacity, then liquid capacity. Okay, so gas capacity formula you have seen already. This is 4d square min. Okay, vertical separator calculation, d square min 5040 TZQG by P rho G rho rho L, other should come negative if we do opposite way, rho G into CD by DM per half. Okay, so this is the formula from two-phase separator is coming actually as it is, and units already you know. D will be in inch, T will be Rankine, Z unitless, this is composite factor, QG is MMSCFD, CFD, P is PSI operating pressure. Okay, rho G your density, CD your drag coefficient, DM is particle size. So this is the formula you have to use for gas capacity thing. Now we will go to settling. Okay, so the requirement for settling water droplet from oil requires the following equation: d square not q, d square equals 6690 qo mu del sg dm square. Okay, so this formula will be there, and next is Vt Vo. So Vt is in feet per second and Vo is feet per second because unit same and value also same. Dm in micron already you know. We are using mu in Cp, capital Pi, right? Okay, and dm is micron. Okay, and Vt formula is there, 1.78 10 power minus 6 del Sg dm square by mu. Okay, so q in feet per second and qo BPD, oil flow rate, maybe it will be given in BPD, so you have to convert into Q. So Q equals QO into 5.61 into feet Q BBL or barrel per day. Day is 24 and hour by 3600. Okay, so finally you are getting 6.49 into 10 power minus 5 Q oil. Okay, now A area equals pi d square by 4. So pi d square by 4 into 144, because you are converting unit. This is in feet, this is in inch. Okay, so you are converting unit feet to inch. So small d divided by 12 equals 1 capital D. Okay, this is 2, this is 3, and one formula I have to write here, I think. VO equals Q by A, flow rate. Okay, 1. Now D in inch. Okay, VO equals 0.0119 QO by D square. It will be coming from 2 and 3. Okay, equation 2 and 3, if we solve properly, so the constant term will be converted and it will be coming like 0.0119 QO divided by T square. Now VO equals VT, okay, right. So 0.0119 QO by D square equals 1.78 10 power minus 6 del SG dm square by mu. Okay, so it will give D square equals 6690 QO mu del SG dm square. Okay, so this formula will come finally. For 500 micron, if I use 500 micrometer dm, then the formula D will be 0.0267 QO mu divided by del SG. Okay, so this will come for 500 micron. So problem will solve later. So I'll write retention time. Okay, retention time formula is that HO plus H water TRO QO plus TRW QW divided by 0.12 H not H D square. Okay, so this is vertical separator, this is oil, gas, water. Okay, so this is HO, this is H water. Okay, retention time for oil is TRO, retention time of water is TRW. So all are in minute actually. This is retention time. Okay, and Q is cubic feet per second. So H is in feet for oil, HO also in feet of water. Okay, so D square H. Okay, so in previous chapter or previous lectures I have shown that D square H equals TRQ liquid divided by 0.12. Okay, so this one, how did we derive? We did like this: T equals volume by Q, flow rate. Okay, so volume we had pi by 4 D square into H, height, divided by 4, H you convert into feet, so it will be coming 4 will not be coming, only 12 will be coming, 4 already given there. So this will be coming like 4.55 into 10 power minus 4 D square H. Okay, now Q in BPD, in BPD, so it will be giving like Q equals Q liquid 5.61 into again the same thing, cubic feet per barrel into BBL into day per 24 hour by 3600. So finally we are getting 6.49 into 10 power minus 5 QL. Okay, and T equals D square H by QL. Okay, okay, so finally this is giving a D square H equals TR QL divided by 0.12. Okay, and yeah, so 0.12 is coming because T and TR, this is in second and TR is minute. Okay, so this formula is coming. Now D square H for oil, let's say this one equation number I can give here, no number is given, right? 1, maybe this one 2. So D square H oil equals TR oil Q oil 0.12, D square H water equals TR water Q water 0.12. Okay, so if we add these two, if we add these two, 2 and 3 gives, we are adding like d square HO, d square HW. So H d square HO plus d square HW equals TRO QO plus TRW QW divided by 0.12. So therefore HO plus HW will be TRO QO plus TRW QW 0.12 d square. Okay, so this formula we get same as 1. Now seam to seam length. Seam to seam length. Okay, so whenever you are calculating seam to seam length, we have to check this formula. LSS equals HO plus HW plus 76 divided by 12, or HO plus HW plus D plus 40 divided by 12. Okay, so any of the formula will be used, but condition is that minimum diameter, D is the minimum diameter gas capacity. So while we will be solving actual problem, we will see which formula to use and which value we have to use for our calculations. So procedure. Okay, in this case also you have to follow step by step for calculation for separator sizing. So first, initially calculate minimum diameter from requirement for water droplet to fall through oil layer. So 500 micron or micrometer you are selecting for water droplet, and you use formula d square 6690 QO mu by del SG dm square. Okay, so mu here oil viscosity, actually not water viscosity. Okay, again next you calculate minimum diameter from requirement of oil droplet falling through gas. So 100 micron you are using, 100 micrometer. D square formula is like this: d square 5040 TZ ZQ by P rho G rho L minus rho G rho L minus rho G C D by dm power half. Okay, now choose the larger of two D. You got two D here, D and D. So select the larger one. Now next step, select larger one, select larger one. Then next is you calculate TR, TRO, TRW. Okay, and you try to solve HO plus HW. So it will be, formula is already given, HO plus HW equals TRO plus TRW QO QW divided by 0.12 D. Okay, now you calculate LSS, HO plus HW plus 76 by 12, or HO plus HW plus D plus 40 divided by 12. Okay, select a size, reasonable size, and LSS by D should be within the limit 1.5 to 3. Okay, within this limit you are selecting LSS by D. Now today we will solve some problem regarding vertical and horizontal separators. So let's see one problem. Flow rate of oil. You have one vertical separator. Okay, and you have 3 layers: gas, oil, water. Inlet is here, and you have outlet, gas outlet. Okay, so oil flow rate you are having 5000 BPD. Water flow rate you have 3000 BPD. You have G, gas flow rate 5 mmSCFD. Pressure, operating pressure is given 100 psi, and T, operating temperature is 90 °F. Some more data are given. Just copy it. Oil API gravity, oil gravity 30 degree API, specific gravity of water 1.07, specific gravity of gas 0.6, retention time both we are assuming equal 10 minute water or oil will be staying inside the vessel, and we will be assuming some values also. CD will be assuming 0.851, Z you are assuming 0.84. Okay, so oil particle size dm oil 100 micron, dm water 500 micron. Okay, so degree API is given, so from there you can calculate specific gravity. Okay, is specific gravity of oil 141.5 divided by 30 plus 131.5, so this is giving 0.876. Okay, so del Sg, specific gravity of oil, Sg water minus Sg oil will be 194, 0.194. Better I'll write all these things. Sg water is given 1.07 minus Sg oil we got already 0.876, it is coming 0.194. Okay, now we calculate D from previous formula 5040 Tz Qg by P rho G by rho L minus rho G, then C D by dm, this is power of half. Okay, now if we put the values, okay, before we put values we have to calculate rho L equals 62.4 into whatever value we got, 0.876, so it is giving 56.6 lb per cubic feet. Okay, rho gas equals 2.70 SPTZ, this is the formula, so 2.7 into 0.6 into 100 psi pressure, T is given 90 degree Fahrenheit, so it will be 90 plus 460 because 550 degree Rankine. Okay, so 550 into Z is 0.84, Z we are assuming 0.84, so finally it is coming 0.35. Okay, if we put all the values for into D, so we will get D equals 29 inch. Okay, now minimum diameter we have to calculate from other formula. D equals that water formula 6690 QO mu del Sg into dm square. Okay, so from there if we put data 6690 into 5000 oil flow rate into 10. Del Sg is we already calculated 0.194 into 500 micron water particle size. So this will be giving 0.8, not 0. Only 83 inch. Okay, so if you see these two values of D, I can get 83 is the major one. So we take 83. Okay, because we got two values of D, but we got 83 higher, so we take 83. Now liquid retention time. Calculation. Okay, HO equals TRO QO divided by 0.12 H12 D square. Okay, previous formula if you see, H water, TR water into Q water 12 D square. Okay, and if we add these two, HO plus H water, okay, so it is coming like 667,000 D square. Now I'll go to next slide. Now we have to calculate combination of D and D, HO plus HW. We have combination you have to calculate, and you have to prepare one table. So D in inch, HO plus HW inch, LSS feet, 12 LSS by D, small d. And if we take D value, let's say initially we got D value 29 and 83, and we have to take the bigger one is 83. So nearby 83, actually 84 we are taking here, and HO plus HW from previous formula we can calculate 94.5, and LSS value, actually you will get two LSS values. You can remember the formula, HO plus HW plus 76 by 12 LSS, and another formula is HO plus HW plus D plus 40 divided by 12. Okay, so if we calculate both, I found that this one is giving higher value, so we will take the higher one. So it is coming 18.2, and if you divide LSS and D, then finally you are getting 2.6 your slenderness ratio. So you can calculate other parameter. Okay, so finally you are calculating LSS value and keep this slenderness ratio 1.5 to 3, so any value can be taken. Okay, and you can say the design parameter values. Now because this is a very big problem, so maybe I can break the problem into small pieces, and then I can ask, like, say, calculate specific gravity, calculate d mean from liquid capacity formula, calculate d mean from retention formula or water particle retention formula, or I can change the dimension, and I can ask you to calculate step by step. Okay, so thank you very much.